electromagnetic fields, various charge distributions and their effects. Review of Coulomb's law. Coulomb's law states that the force capital F between two point charges Q1 and Q2 is 1. Along the line joining them, 2. Directly proportional to the product Q1 and Q1 Q2 of these charges, 3. Inversely proportional to the square of the distance capital R between them. Mathematically we can write that capital F is equal to K Q1 Q2 divided by R squared. Epsilon naught is equal to 8.854 into 10 to the power minus 12, and K is equal to 9 into 10 to the power 9 meter per farad. F is equal to Q1 Q2 divided by 4 pi epsilon naught R squared. If point charges Q1 and Q2 are located at points having position vectors R1 and R2, then the force F12 on Q2 due to Q1 is given by F12 is equal to Q1 Q2 by 4 pi epsilon naught R squared A R12. F12 is equal to Q1 Q2 R2 vector minus R1 vector divided by 4 pi epsilon naught R2 vector minus R1 vector magnitude Q. Principle of superposition. If we have more than 2 point charges, we can use the principle of superposition to determine the force on a particular charge. The principle states that if there are capital N charges Q1, Q2 and so on Q1 located respectively at points with position vectors R1, R2 and so on up to R capital N, the resultant force capital F on a charge Q located at point R vector is the vector sum of the forces exerted on Q by each of the charges Q1, Q2 and so on up to Qn. Hence, we can write that capital F is equal to Q divided by 4 pi epsilon naught sigma k is equal to 1 to capital N Qk R minus Rk by R minus Rk magnitude R minus Rk Q. Now we can write electrical field intensity capital E is equal to Q divided by 4 pi epsilon naught R squared AR is equal to Q R minus R dash divided by 4 pi epsilon naught magnitude R minus R dash Q. For n point charges Q1, Q2 and so on up to Q capital N located at R1, R2 and so on R capital N, the electrical field intensity at point R is obtained as follows. E is equal to Q1 R minus R1 divided by 4 pi epsilon naught R minus R1 cube plus Q2 R minus R2 divided by 4 pi epsilon naught R minus R2 cube plus and so on plus Qn R minus Rn by 4 pi epsilon naught R minus Rn cube. E is equal to 4 pi 1 by 4 pi epsilon naught sigma k is equal to 1 to capital N Qk R minus Rk by R minus Rk cube. Different charge distributions have been shown on this particular slide: point charge, line charge, surface charge and volume charge. For line charge we can write dq is equal to rho l dl or q is equal to line integral of rho l dl. For surface charge dq is equal to surface integration of rho s ds. For volume charge dq is equal to volume integral of rho v dv. Now we can write E is equal to rho l dl by 4 pi epsilon naught r squared ar for line charge. E is equal to surface integration of rho s ds by 4 pi epsilon naught r squared ar, and E is equal to volume integration of rho v dv by 4 pi epsilon naught r squared ar. This is for volume charge. Surface charge. For surface charge, dq is equal to rho s ds, q is equal to rho s ds, and dE is equal to dq by 4 pi epsilon naught r squared ar. E due to volume charge can be obtained by taking reference from the following diagram.